All right, I'm pretty sure that 1 works. I did this mentally, tried a few times, and this turns out to work. Now, if that equals 0, that means x minus 1 is a factor. All right, and so then I take 1, and I'm going to divide it into this polynomial. And you can see it works. All right, so then I have one of the factors. Now what I need to do is take a look at what's left and come up with another factor. So what I'll do is I'm going to try x minus 2. So f of 2, and I'm going to go 2 times 2 cubed plus 2 squared minus 13 times 2 plus 6. And this turns out to be 0. So x minus 2 is another factor. Let's divide that into our polynomial. So here's what I have. F of x is x minus 1 times x minus 2 times 2x squared plus 5x minus 3. And if I factor that, there it is. Now normally you will not get a question where you have to factor out 4 factors and then graph it. Usually this is a question you would get just like that. I would ask you to factor fully and you'd be done. The problem with this is if you make a mistake with your factors, then your graph is also going to be wrong. So chances are it's not going to be a question like this all put together. They would be separate. So factoring, maybe that's a 3-mark question. Now let's graph this. This allows me to know what the x-intercepts are. They're 1, 2, half, and negative 3. Alright, I should quickly figure out what the y-intercept is as well. I believe it's 6. Oh, it's negative 6. Okay, so let's go and put that all on the graph. Put negative 3 here. And then I have half, 1, and 2. And negative 6. Now, we should be able to kind of know what this graph looks like already. This is a quartic with a positive lead coefficient. So that's supposed to mean I end up like this. And so far what we've seen every time is that the graph will always cross at the zeros. So, you know, if you did a quick sketch here, this looks like it would do something like this. Alright, and that turns out to actually be what we have. So we could check the sign diagram to be sure, but for now, every time it has crossed at the x-intercepts. We'll talk very quickly, or it may think in the next lesson why sometimes it doesn't cross, but this one does cross. So let's try to draw this completely. Alright, now this is a little bit weird. The negative 6 to the half is very tight. So what I want to do here is I'm probably going to try to draw it down like that so I can make a smooth curve. And then I won't go very high here or low here so I can make the graph look continuous like that. So there's my graph of that polynomial. Okay? Again, every time we've crossed at the x-intercepts, let's talk about when we don't cross. And this has to do with what's called the multiplicity of 0. okay? Or the idea that there is a repeated root. What is a repeated root? Well, in this quadratic, a parabola, it can be written as x minus 1 squared. Therefore, the root, or the x-intercept, is 1. And we say that has a multiplicity of 2 because there are 2 of them. It's x minus 1 times x minus 1. Okay? Thinking about what that graph looked like, here it is. This is our x-intercept at 1, and you can see at that x-intercept we have something that we call a bounce. It doesn't cross the x-axis. It bounces there. This happens when there is a multiplicity that is even. Okay, we'll see more of those in a second. What happens when we have a multiplicity that is odd? So here we have x minus 1 cubed, the cubic function. Okay, there our x-intercept of 1 has a multiplicity of 3. What happens there? Well, you can see this time it crosses, but it doesn't cross like that, like a linear graph. It crosses with what we call a cubic wave, because the multiplicity is 3. Okay, now that's a little bit confusing. Let's talk about that. So the difference in behavior. What happens at the 0? It has to do with what the multiplicity is. In general, this is kind of a generalization. If the multiplicity is even, the graph touches the x-axis, but doesn't cross. If the multiplicity is odd, the graph crosses the x-axis. Okay? But that's not quite enough. So if we have a multiplicity of 1 versus a multiplicity of 2 versus a multiplicity of 3 or 4. Let's actually change this. Let's make it 1, because that's what we were talking about. If we have a multiplicity of 1, at 1, it's going to cross. If we have a multiplicity of 1, it's going to bounce. Sorry, that's a multiplicity of 2. If we have a multiplicity of 3, it's going to cross, but it's going to cross at a wave. In fact, if this was a 5 instead of a 3, that wave would be even flatter. Generally speaking, the higher the multiplicity, the flatter the behavior at 0 is. So here you have an even power. All right, it's going to bounce at 1, but because 4 is bigger than 2, the multiplicity is greater, it's not going to be a bounce like this, it's going to be a flatter bounce. Okay, when I mean flatter, it's like the behavior here at 1 is almost like it gets flatter. If this was a power of 6, what would that look like? Well, that's squared. If that's the power of 4, power of 6 would be even flatter. Okay, so we'll try to do some of these. I'll try to give you an example of what kind of behavior we're looking for. So here is one. Let's take a look at this graph. What are the x-intercepts? -1, 2. What's the y-intercept? Well, if we make x be 0, you get 0 plus 1 to the power of 4, 0 minus 2. So this is going to be -2. What kind of graph is this? Well, you have x to the power 4 times x. This is what we call a quintic. Right? It's x to the power 5. So we already know this graph is going to end up like this. Okay, we should keep that in mind as we draw it. Here's our x-intercept of -1. Here's our x-intercept at 2. And here's our y-intercept at -2. Okay? So we know we're ending up here. We know we're going to end up down here. What's happening at our zeros? Well, at the 0 of 2, we have a multiplicity of 1. That means it's going to cross. So I know it should do this. Okay, which makes sense because I want to go down to -2. And then I look at -1. The multiplicity is 4. This tells me even multiplicity, it should be bouncing. And this makes sense because I'm coming up here from the negative and I want to end up negative. So I want to bounce here at -1. But I don't want to just bounce, I want to bounce quite flat because it's a higher power than 2. Alright, so let's put this all together. Let's see if we can draw this graph. Okay, I know I'm starting down here, and at that 0 I want to bounce, and I want to bounce quite flat. Then I'm coming here and crossing there. Okay, there's my graph. Alright, let's try another one. Pause the video and try this on your own. Alright, so x-intercepts -1 and 3. Y-intercept is 3. This is a power of 4, x cubed times x. So this is going to be a quartic. And so I know that it's either going to have both ends going up or both ends going down. Well, what's the lead coefficient here? The lead coefficient is negative. So this is going to be a quartic going down. Okay, so in my head I'm thinking down here. Alright. So what's going on? Well, at 3, the multiplicity is 1. So I'm supposed to just cross. That means I'm going to somehow go up here. And then what's happening at -1? I don't want to just cross. I want to cross with a cubic wave because this is a power of 3. So I should do something like this. It should be some sort of a wave. Alright? Which makes sense because if you just draw this without that wave, you end up with what looks like a parabola. This is not a parabola. This is x to the power 4. So let's try and draw this. Okay, I'm going to draw the cubic part first because that's a little bit tricky. So I want to cross with a little bit of a wave there. And then I want to cross this y-intercept, and then I want to cross 3 normally. So it should look something like that. What would I be looking for? Again, I don't care how high you go here. It doesn't matter. What I'm looking for is, do you recognize that there is a cubic wave here? Okay, that has to happen. That's critical to getting full marks. And then, is it a smooth curve? Do you have your x and y intercepts labeled? Okay? Alright, we'll stop there for today's lesson. Your homework, you can do page 46, numbers 3 to 8. You can do page 50, numbers 9 to 13. And I'm going to strongly recommend that you do some of the practice questions on your web page, the review that I've posted with full solutions. Make sure you try some of these. If you have questions with anything, please send me an email. All right? Good luck.